Okay, so we're going to take a look at question 7.75a. So we have a secondary alkyl halide. We have a strong base, and it's also a weak nucleophile. Right, T-butoxide is too big and bulky to be a good nucleophile, but it is a very powerful base. And we have two types of beta protons here. I'll just scribble this one in red. And then we also have these ones in black here. We have those two types of protons. If I pulled off the proton in red, I would end up with this alkene. It's going to look like that. And if I pull off the one in black, I'm going to end up with something that looks like this. Okay, but keep in mind that this is a trans compound, and I could also have the cis compound as well. So I'm going to draw the cis compound as well. So we've got a total of 3 products, but remember we're using a hindered base in this case, and so the Zaitsev product is not going to predominate. It will actually be the Hoffman product that will predominate, and so the Hoffman product will be the major product. So I'll just write major product for this one. All are going to be present, but that will be the major product. All right, if we look at the next one, so we're starting it with 1-chlorobutane, or you could call it butyl chloride. Either one is totally fine. So we have a primary alkyl halide, and we have sodium hydroxide. So hydroxide is a strong base, and it's also a strong nucleophile. And so since we have a primary substrate, SN2 is going to predominate. We're going to get SN2, but we're also going to get some E2 as well. Okay. On the first one, I didn't write down the mechanism, but this is an E2 mechanism for all of those. Anyhow, so let's get back to it here. So first, let's draw the product of the SN2, since that's going to be the major product. And so what we're going to end up with in that case would be just replacing the chloride by the hydroxide. So again, this will be our major product. This is the SN2 product. But as far as an E2 product goes, there's only one type of beta proton here. If this is our alpha carbon, then this would be the beta carbon over here. And so if we eliminate that, we're going to end up with 1-butene, this compound here. And so this would be the minor product, and this is the E2 product. Now keep in mind there's no cis and trans for this. There's just this one compound, and that's it. So we get 2 compounds in this specific case. If we move on to 7.75c, here we have a secondary alkyl halide, and we have ethoxide, which is a strong base, and it's also a strong nucleophile. And so what does that mean? That means the E2 is going to predominate, but we're also going to get some SN2, and we also have a stereocenter here. So if we just start with the SN2 product, I think that's probably the fastest one to draw. The SN2 product is just going to look like this. We're going to change our wedge to a dash, and we have this ether out here now. So that is going to be the SN2 product. But as far as the E2 products go, I have this type of beta proton, and I have this type of beta proton. Oops, I'll need a different color. So we have this type of beta proton. If I pull off the proton in red, I'm going to end up with, if I pull off the proton in red, I end up with something that looks like this. If I pull off the proton in blue, then I end up with this compound. But as we saw in the previous example, we also have the stereoisomer, which is going to be this compound. Now, since I have an unhindered base, keep in mind this is unhindered, okay? That means the most substituted alkenes are going to predominate, but the one that is less sterically hindered is going to be the major product, right? So this is E2 product, and these are all E2 products, okay? These are all E2 products, but again, this one is the least sterically hindered, and so there you have it. So we end up with a total of 4 products. In this case, because we get inversion of configuration, right? So what happens is, remember, when you have an SN2, you always have backside attack. So the bromine is coming out towards us, And so when the ethoxide attacks, it attacks from the rear face of the molecule. So this is backside attack. And when we have backside attack, it results in inversion of configuration. Always. Okay, so we get nucleophilic attack, and then we get our loss of leaving group, and then we end up switching the stereochemistry. All right, so in SN2, if there's a chiral center, it will always result in inversion of configuration. Does that make some sense? Okay, cool. And that's an SN2 topic. Okay, so SN2 gives you inversion of configuration based off of backside attack. All right, let's keep going. Next one is, this is again question 7.75. This is 7.75D. Here we have a tertiary alkyl halide, and then we have sodium ethoxide. Ethoxide is a strong base and a strong nucleophile. Well, we aren't going to get any nucleophilic attack on a tertiary alkyl halide, so we're only going to get E2 in this case. And we have two types of E2 protons. We have these ones here, and we have these ones here. So if I pull off the proton in red, I would end up with this compound. And if I pull off the proton in blue, I would end up with this compound. Now keep in mind, this is an unhindered base. And so the more substituted alkene is going to be the major product. So this would be the major product, and this would be the minor product. And of course, they're both E2 products. Now keep in mind, there's no cis and trans for this one. So no, put here, no cis or trans for this guy, right? Because this carbon has two methyl groups attached to it, so there cannot be any cis or trans for that one. Give me a thumbs up if you're with me so far. Right, just thinking, you know, I just need to practice this on my own. Absolutely, absolutely you do. Let's just try a couple more and then we'll call it a day. So let's try question 7.75E. So I'll just put it down here. So this is 7.75E, and we're starting out with, hey, what do you know? We got a chiral center. So we're starting out with this alkyl bromide, and it's actually benzylic, isn't it? And we're putting it in sodium ethoxide. So ethoxide is a strong base, strong nucleophile. We have ethanol as the solvent. And what are the products going to be? Well, we've got a secondary alkyl halide. We've got a strong base, strong nucleophile, and it's unhindered, but it's secondary. So E2 is actually going to predominate in this case. But we've only got one type of beta proton, which is this one here. So that means if we were to pull that off, we're going to end up with something that looks like this. But what do you notice about this compound? This is a trans compound, and so we could also get this cis compound, which is going to look like this. So we get the trans and the cis. Could anybody tell me which one of these is going to predominate? Would it be the trans or the cis for this E2? Keep in mind, these are both E2 products. Exactly. Thanks, Isaac. It's going to be the trans. This would be the major product. Why? Because it's less sterically hindered. Absolutely. And then for the substitution, right, it's going to be an SN2 reaction. And so we're going to get inversion of configuration. And so the SN2 pathway is going to give us this compound, where now we have our ethoxy group on here like this. Remember, we get inversion of configuration in an SN2 reaction. Okay, so we switch the wedge to a dash or a dash to a wedge. All right, so I'm not going to solve this one with you, but I do want to take a look at it, and we're going to solve it on Monday. And this is question 7.75F. Okay, so we're going to start with this compound. Watch carefully. We have a bromine here on a wedge. We have a methyl group here on a dash, and then we have, an ethyl group like this. And so we have a secondary benzylic halide, and so we're going to treat that with sodium ethoxide. And remember, ethoxide is a strong base, and it's also a strong nucleophile. And since we're secondary, we're going to get mostly E2, but we're going to get some SN2 as well. Now the SN2 product, for that, all you have to do is invert the stereocenter and replace the bromine for the ethoxy group. So we just have to do this. So we'll change the wedge to a dash, put in our ethoxy group, keep this methyl group intact, and then have something like this. That is our SN2 product. But what I would like you to do for next class is, since there is only one beta proton, right? This is a beta carbon, it's got no protons. This is a beta carbon, and it has one beta proton on it, this guy here. What I'd like you to try to do is to draw the Newman projection in this perspective, looking down the carbon-carbon bond this way, and you can see that the bromine and the hydrogen are not anti-periplanar to each other in this conformation. So you're going to have to draw a Newman projection, okay, where you have the phenyl coming down like this, then you have the ethyl group going up in the back. I'll let you figure out the rest. Before next class. And then what you're going to see is, once you fill this out, you're going to have to manipulate that Newman projection and figure out whether you end up with the E alkene or the Z alkene. Is it E or Z? And we will solve this first thing in class on computers. This is a joke. On June 10th. Okay, we're going to take a look at this problem to start the day.